and this what you see is a very dangerous high voltage power supply. It is 35 watts, and as you can see, the maximum output voltage is going to be 23,000 volts, danger to life. And this is the input pin, positive and negative, which I'm going to connect with the help of two jumper cables, red denoting positive and black negative. This is a small mobile charger, 5 volts 2 amperes output. This is what I'm going to use right now to excite it. As you can see guys, that the arc is really thin because the power supply or the input power that is activating the circuit is very less. So I'm going to switch it to 12 volts 7Ah. So guys, as you saw that this time the arc was really thick. It was the high voltage arc category, violet and green. So this was working pretty good. Now let's experiment with this mercury lamp, a dead one. Okay, it is 250 watts, and as you can see that it is glowing. Not bright enough, but because it's a fused one. Now let's do the same with dead CFL. As you can see that it is glowing. Oh, pretty bright. Now it is really bright. So hit like if you liked it. Now this bulb is also a dead one with a lost or burned out fused filament. Okay, so what I'm doing is I'm giving high voltage and electrons are jumping from one terminal to the other, and it's the plasma arc similar to a fire flame. And when I turn it off, you can see that the terminals are red hot, and when I lower the voltage, the plasma is violet in color. Okay, so this is a small 3 volts DC motor, and these are some 20,000 high voltage diodes. Okay, so I'm going to use these diodes to create pure DC, like half wave pure DC, and connect it in series with the motor. And I'm going to connect two diodes in parallel, as you can see, so that we can get the maximum current flow. Okay, guys, let's do some RPM testing of the motor for its speed measurement. So the maximum RPM for that motor was as high as 46,000 RPM, which was pretty good indeed. Now guys, this is a 24 volts 50 watts DC motor. Let's try this one and see how much RPM we get here. Oh, the speed is not even reducing, it keeps on accelerating and accelerating. That was really dangerous. The problem is that this wire is getting really hot. Maybe it's drawing huge amount of current, and that too continuous because the voltage is very high but the current is not that high, because of which the starting is very slow but it keeps on increasing to achieve the highest RPM equivalent to the voltage 23,000 volts. Let's try once again. Now guys, this is a 220 volts blender motor. Well, the speed was not much. Let's try reversing the diodes and hope that it works well this time. Whoa, I reversed the diode and it seems like it is performing much better now. Wow. This device that you see is a AC DC motor speed controller plus dimmer, and you can see that there is a knob to control the speed of a motor. Now many of you asked me how I made this device, so today in this video I'm going to show you that. This what you see is a motor speed controller, 220 volts max and 4000 watts maximum power. You can see here there are 4 terminals. So these 4 terminals, 2 are input and 2 are output, and you can see there are holes present on the casing to allow heat from the circuit and let the circuit cool down. The speed is controlled from 0 to full, and the full circuit is compact and metallic, and the knob is really smooth, and it is big enough so that it can easily be rotated. So let's open up the case and see how the circuit looks from inside and what the components are. And I must tell you that this is an SCR controlled motor speed controller. Now guys, the cost of this device is around 550 Indian rupees, and as you can see, the case is a little bit tight and there are no screws available, some kind of metal lock. Yeah, now it's open and you can see the circuit inside. It looks really nice. There is a fuse, resistor, capacitor, 4 terminals and a big huge heatsink with a large SCR mounted on that heatsink. No wonder it is rated for 4000 watts, and that is a bridge rectifier. Okay, so that's the controlling part, and that is a 500 kilo ohm resistor potentiometer. So let's do the connections. Here I'm going to use 2 wires, 1 square wires, and the red I'm going to use for the input and yellow I'm going to use for the output. Guys, a few of you might say that I'm using thin wires considering the power rating of this controller. Then I must tell you that this is a demonstration video. I would recommend you to use a max of 4 wires because the current is going to be only as high as 18 amperes, that is at full 4000 watts. So with that being said, let's move on to the wire connections. You can see that the case indicates the input connections and the output connections. The terminals on the left hand are the input, so the red wires will be connected to the left terminals, which are going to be the input, and you have to curve the wire a little so that it gets in completely, and same for the other one. So now your input terminal is done, and the other last two are going to be your output terminals, which are, as I said, the yellow, which I'm choosing here. So yellow are the output and red are the input wires. Now let's test it with a 100 watt incandescent bulb. So yellow wires are the output, so the bulb is connected to the output, and as you can see that it is working really nice with the knob. Performance is working from 0 to full quite smooth. Okay, let's turn it on once again, and here as you can see that there is no change in voltage with the turning of knob. That is because it is an SCR controlled speed controller, and an SCR controller only changes the angle, the firing angle, but the peak voltage remains the same. But if we connect a bulb with it, the voltage will reduce and increase accordingly. But in this case, somehow the voltage is going beyond 220 volts. I don't know what is happening. Sometimes it happens with this type. You can see that the voltage went as high as 1171 volts. Yeah, so that is the bad point of this regulator. Now let's test it with this fan. Now it is an induction motor fan, simple, and you can see that this controls it really well. The fan is 70 watts, so this load is nothing for this speed controller, and you can see that the controlling is really smooth. I'm really satisfied with this, except for the fact that when you turn it off with the switch, there is a pulse which gives more than full output. Now guys, this what you see is a 220 volts 500 watts universal motor from a sewing machine, and I've connected a pulley to its shaft so that it is easier for you to judge and see the RPM control and shaft movement of this motor. So let's start it. And as you can see that the starting was really slow, which indicates smooth start and smooth running as well. With the sound of it, you can see that the RPM is really high. It is working pretty good, guys, and yes, I'm satisfied with this. Oh, very high RPM. More. Now guys, the previous motor that you saw was this one 500 watts motor from an old sieving machine. So now I'm going to use this 960 watts washing machine motor. This one is also a universal motor that can run both on AC and DC. You see, very thick windings have been used. So let's test this controller with this big motor. Now guys, the maximum RPM of this motor is up to 14,000, and from the sound of it, I think it's believable. This what you see is my mod for my tachometer. Now the tachometers that are available in the market usually come with two AAA batteries which drain really fast because of the laser pointer installed in the tachometer. So to prevent that or to tackle that situation, I constructed this device or modified it into a rechargeable one by using two 2000 mAh lithium ion batteries. and now it works really well, as you can see, and the batteries drain in around 5 or 6 months or so, and when they do, I can easily recharge it. And guys, this what you see is a motor alternator set, and this motor is going to be driven by that speed controller box. This is the back side of the car alternator, and the small and thin red and blue wires that you see, those are for exciting the rotor winding of the car alternator by connecting a 12 volts battery. And to the left of it is a custom made 3-phase rectifier, since the original rectifier broke. Link for its construction video will be provided in the description, you can check it out. That's the battery I'm going to use for the excitation of rotor winding of the car alternator. And guys, there's one thing I forgot to tell you. Full output of the car alternator will appear on these two terminals, red and black. So guys, now it's time to connect this 12 volts UPS battery and these two jumper cables to the rotor winding terminals of this alternator. Okay, red will be connected to red, and blue is going to be the negative, although polarity does not matter here. And you see, the connection has been successfully made. So guys, before starting the machine, let's point the meter towards voltage measurement mode and connect the pins and the pin outs to the output terminals of the alternator. So meter terminals have been successfully connected. So guys, you can see that the tachometer is fully set and the meter at present is pointing 0 volts. So let's connect the battery terminals to the rotor winding and start the test. Okay, so first let's turn on the motor and the laser pointer. So guys, here as you can see that I'm getting here around 1300 RPM and the voltage is around 1.5 volts, and it is happening something with my hand. So anyways, that is just the ripple effect. Okay, so anyways, I have not connected this terminal from the rotor winding to the battery to activate the rotor. So let's do that and check the change in RPM and also see if it reaches 12 volts or more or less. You can see that the RPM has reduced to 1000 and the voltage is around 11.45. So we will have to increase the RPM a little bit. So I'm going to do it from here. That's the knob. Let's keep this connected. And here we are getting around 11.7 volts at 1200 RPM. Although fluctuating a lot. Increasing it a little bit. And the voltage is also increasing. Yeah, so 1300 RPM. Yeah, 1300 RPM is at what the alternator is producing exact 12 volts DC. Okay, so that's all for today's video, guys. Let's turn off the setup, first removing this terminal. And you can see as soon as I remove the terminal, the speed increased, because when the electromagnet gets excited, the RPM reduces because this motor gets loaded. So it takes little more power from the source to compensate for the lost RPM.